So I'd like to introduce Carl Luetzelschwab to this month's Portland Amateur Radio Club presentation titled Cycle 25 Update and Understanding Space Weather. Thanks for joining us again, Carl.
You're welcome. Yeah. Thank you, Max. Let's see, I guess you're going to drop your share screen here?
Yes. Thank you. There you go.
Okay. Let's see here. Okay, it just came up full screen for me.
Let's see, I don't see it quite yet. It did say that it's starting to share.
Okay.
There we go.
You know, it's a long way from Portland to Fort Wayne. Those electrons sometimes, slow down a little bit or something like that. Okay, everybody ready, I guess? Good evening to everyone. And I think most are in the evening. We certainly are here in Fort Wayne. We're 3 hours ahead of you. It's 10:30. So I'm Carl, K9LA, and we'll talk about understanding and applying solar indices, and also at the end give a quick update on Cycle 25, which is pretty important. So a little bit about me. Again, I got my novice in 1961. There's my novice QSL card. I enjoy trying to understand propagation. I enjoy DXing and contesting, mostly casual now to say hello to old friends. Enjoy traveling to hamfests and conventions, and one of these days we're going to do that again, I bet. We'll have to wait and see. And also, I really enjoy fixing and using vintage equipment. That's my novice and early general station and national NC60 receiver. Heathkit DX35. If you look under the receiver, there's WPE9BQH back in the 60s. Popular Electronics registered you as a shortwave listener. And darn, that was my first license, although it's not really a license. And I still have their certificate from Popular Electronics. Graduated from Purdue many years ago, and I was an RF design engineer by profession, first with Motorola, and then with Magnavox, which went through a bunch of name changes, and now it's Raytheon, so whatever. And I'm currently the ARRL Central Division Vice Director. My wife is Vicky, AE9YL. It really helps that she's a ham because she enjoys a lot of the same things I enjoy doing. Unfortunately, she's a little bit younger than me, and she's still working, but this will be her last year. So hopefully she'll be able to devote a little bit more to amateur radio in the future. So let's see what we're going to talk about. Just a quick caution. Talk about space weather data sources, where we can get a lot of data. What parameters should we look at and how they affect propagation? And then Cycle 25. And our kitty cat just came in the room, so maybe you'll see a tail here walk by in a little bit. So what we try to do is simplify very complicated atmospheric and ionospheric processes into simple statements about HF propagation. That's okay for a long-term look at propagation. And when I mean long-term, I mean kind of over a month time frame. That's why our propagation predictions give monthly median values, mostly the maximum usable frequency, the MUF, and signal strength. Median implies 50% probability. Thus, our predictions are statistical in nature. We don't have daily predictions yet. We have lots of trouble predicting propagation in the short term. Like how good is tomorrow going to be? Realizing what happened today. And what about some enhancements? What about degradations that come along? Well, we really struggle with those things. And here's a good example of the day-to-day variability of the ionosphere. On the left is a plot of the maximum usable frequency over the Wallops Island ionoson for August 2009 at a certain time, 1700 UTC. It's around local noon. Now what you can see is the MUF varied day to day by a factor of about 2 to 1. The lowest was about 11 megahertz on the 14th of August. The highest was about 22 megahertz on the 16th of August. So why did it vary that much? Well, if we look at some space weather data on the right there, the black is the solar flux. You can see in August 2009, it was pretty darn constant. Probably over the whole month of August, it varied from about 66 to 68 or so. Red is the sunspot numbers. So in August, the sunspot numbers were 0. There were no sunspots for that whole month. And the planetary A index, which is an indication of how active the Earth's magnetic field is, which could cause a degradation in the F2 region. It was kind of quiet, relatively quiet. So why did the MUF vary by a factor of 2 to 1 when the solar flux was constant and the sunspot number was 0? Well, the problem is the sunspot number and the solar flux and the geomagnetic field activity are just 2 of the 3 parameters that determine the ionization at any point on Earth. The third one that we're starting to learn about more, but we don't have a handle on it yet, is events in the lower atmosphere that couple up to the ionosphere. So until we understand that, we're not going to have daily predictions. It may take quite a while to figure all this out, but at least there's lots of research going on about it. Okay, what are some space weather sources? And we'll also explain some of the parameters that go with them. Well, the first bullet is N0NBH's banner. It's a very colorful banner. There's his website. And this banner is found at many places. QRZ.com is one that's probably very common with a lot of people. Another good data source is from Dr. Tony Phillips at spaceweather.com. Again, we'll discuss all of these here in the next several slides. The Space Weather Prediction Center, SWPC, which is part of NOAA, they have their website at www.swpc.noaa.gov. VE3EN runs solarham.net at that website. And of course, there are videos by Dr. Tamitha, Whiskey X-Ray 6 Space Weather Woman. And there's the URL for her videos. A good summary of what the sun is doing and how it affects propagation. There are many other general websites, and there are a heck of a lot of others that are more specific and drill down into a particular parameter. So let's take a look at the N0NBH banner. Again, I pulled it from QRZ.com. Today at 23:19 UTC, 23 is 13, 7 is 4 at 7 o'clock here in Fort Wayne. And of course, the date and time are quite obvious. SFI is the 10.7 centimeter solar flux index. You can see it was 82 today, or at least at the time it was reported. SN, today's sunspot number, 0. So with the solar flux down around 82 and the sunspot 0, we're still at solar minimum. Okay, that's something good to remember. The A index is an index for yesterday of the activity of the Earth's magnetic field. It's the average of the 8 3-hour K indices. The K index is the current 3-hour index. So in the time frame of 21 to 0000, it was a K of 1. The PLNTRY after that tells you that it's a planetary index, which means it's not just from one station, it's from several stations worldwide to give a more worldwide picture of how active the Earth's magnetic field is. The X-ray parameter tells you what the background radiation is at X-ray wavelengths, which is 0.1 to 0.8 nanometers. It's very short. It's responsible for basically the D region. And solar flares are classified as A, the smallest, B, C, M, and X, the largest. It's a log scale, so it's a magnitude of 10, each increment up to the next level. 304A is ultraviolet, extreme ultraviolet radiation at 304 angstroms, which is 30.4 nanometers. And it's interesting to note that from 26 to 34 nanometers, that wavelength is responsible for about 60% of the F2 region. So that 304A is a good number to have on that banner. And 1, 2, 3, 4, 5, all 6 of those parameters are highlighted in the goldish box there at the top left. There's some more stuff. The box is moved down to some more of the parameters. The PTN FLX is the proton density in the solar wind. It's at a specific bucket of proton energy because it's measured at several different ranges. ELC FLX is electron density in the solar wind. Again, it's measured in a certain electron volt range. Aurora is a scaled power from 1 to 10 into the auroral oval. How many electrons are precipitating into the auroral oval? And it loosely correlates to the K index. I'll have a little bit more about that later. AUR lat is the lowest latitude impacted by aurora. So today at 2319, it says 67.5 degrees. So that's still quite a bit north of me. I'm at about 41 degrees north latitude. So things are pretty quiet, in other words. SW is the solar wind speed in kilometers per second. Quiet time is an average of about 400. So it looks like the solar wind was not very enthusiastic at the time it was measured. The BZ, I skipped it. Okay, BZ is the component of the interplanetary magnetic field that we're most concerned about. BZ is perpendicular to the ecliptic, which is the plane in which the Earth goes around the sun. And it's pretty much in a north-south orientation in relation to the Earth's north-south poles. MUF US Boulder is the maximum usable frequency in megahertz at the Boulder ionosphere. So that's a good indication of what the ionosphere is doing right now. As you can see, it was 15.85 megahertz. So if Boulder was the midpoint of a 3,000 kilometer path, 20 meters should probably be open, and maybe even 17 a little bit. It's getting close enough that you got to look at that. Okay, the next source is the spaceweather.com. In the left column on the home page, you'll see a bunch of data, solar wind data, X-ray solar flares, sunspot numbers, spotless days. the radio sun, which is at 10.7 centimeters. A lot of the parameters that were on the N0 NVH banner are on this, on the left column here. In the middle column, lots of good discussion and data on a variety of subjects. Dr. Phillips talks about coronal mass ejections, CMEs, talks about aurora, near-Earth asteroids, cosmic rays, and many links to specific data. So there's a lot of information that's probably outside the realm of what we're interested in propagation, but it's surely, a lot of good information out there just to have a good read about stuff. Get you up to date on this whole Sun-Earth system. Okay, the NOAA website, Space Weather Prediction Center. At the top of the home page is the letters R, S, and G. And what that is the three categories of disturbances to propagation. G is a geomagnetic storm. It's caused by an Earth-directed coronal mass ejection or a coronal hole. S is solar radiation storm. It's due to energetic protons from a big solar flare. R is radio blackout. It's due to X-ray radiation from a big solar flare. And I should mention that you don't have to memorize any of this because I will send Max a copy of this presentation, so that may help. The scale for GSR is, each one is 1, which is minor, to 5 extreme, and all the details are at that URL there at the bottom of the page. So it's just good to know that there are disturbances to propagation. We'll talk a little bit about them in a couple slides here. There are also 6 panels on the home page at Space Weather Prediction Center. The top left is the sun in extreme ultraviolet wavelengths, 19.5 nanometers. It's not the same as the 30.4, but you can see some bright spots, which will be good for the F2 region. Top in the middle is coronal mass ejections. You can see the dark blue circular occulting disk, which covers the sun, and that allows us to see ejections and flares and all that kind of stuff. You can see that there looks like there was probably a coronal mass ejection on at least the date of, let's see, that would have been January 7th at 1606 UTC. The top right is the aurora forecast. Again, that was for the date earlier this year. And everything looked kind of greenish, which means things were kind of quiet. When it's yellow, orange, and red, then we got to start worrying about a disturbance affecting the F2 region. There's the X-ray flux as measured by the GOES satellite, which is in geosynchronous orbit, geostationary. You can see there weren't very many flares. There's some little red blips there. Those are solar flares of very low magnitude. Remember, I mentioned it goes from A, B, C, M, and X. So these are the lowest solar flares. They're barely above the background radiation. The middle bottom is the proton flux measured by the GOES satellite at geostationary altitudes, geosynchronous altitudes. It's not the same proton density as the N0 NVH banner. And the bottom right is the estimated planetary K-index for 1, 2, 3 days. And that's where the K-index on the N0 NVH banner comes from. If the K is 1 to 3, or no, 1 to 3, it's green. If it's 4, it's yellow. And if it's above 4, like 5 up to 9, it's in red. So things were kind of pretty quiet, at least during the period that this graph is from. What I probably should have done is pull this for today, and I forgot to do that. Here's the solarham.net site by VE3EN. That's got a lot of data, a lot of the same data. It gets a little bit more into detail. It talks about active regions. It talks about magnetograms, which allows us to determine the polarity of a sunspot. That's good in determining whether the sunspots from the old cycle or the new cycle. Visible sunspot regions are in the left column going down. There's also all kinds of other data, temperature of the solar wind, and all kinds of stuff. And of course, the guy there down at the bottom, he's just sweating his head off because, man, there's a lot of data there. Phew, right? Right. So which parameters should we look at as HF propagation gurus, aficionados? Well, I think there's just a certain subset of all that data that's important. The first one is looking at the first one are those 4 parameters, and they're very related. The solar flux index, 10.7 centimeter solar flux, the sunspot number 304A, and the MUFUS boulder. They all tell us, give us an idea of how much ionizing radiation there is for the F2 region. Now, the F2 region is the one that's most important for our long distance contacts. So that's good to know. In other words, that's going to tell us which of the higher bands are open. Okay, X-ray is something good to look at. It really ties into, are there any disturbances to propagation? Could tell us that there are some very energetic particles from some big solar flares, M and X category, that could cause a solar radiation storm, which is increased absorption in the polar cap, and that would degrade over the pole paths, for example, from Oregon into deep Russia or India, VU. Also, a big solar flare can emit very short wavelength radiation, X-ray radiation, and that can cause a blackout on the daylight side of the Earth, which, everything goes away. It comes back in maybe a half an hour or less. And the other parameters that are tied together are the K index, the A index, the BZ, the solar wind, and those GSR categories that we went over. They tell us how active the Earth's magnetic field is. And the more activity, the worse the F2 region could be. So those tell us if the F2 region is going to take a hit. So how do the parameters impact propagation? Well, let's look at the first bucket of parameters, the solar flux, the sunspot number, 304A, and the MUF over the Boulder ionosonde. We have to remember that the 10.7 centimeter solar flux and sunspot number are proxies for the true ionizing radiation, which is extreme ultraviolet for the F2 region. So that's why that 304A parameter is kind of important. Now, here's something we got to remember, that at solar minimum, when the solar flux is down around 65 to 70, the sunspots can be 0. There's still enough extreme ultraviolet radiation from the sun to keep 20 meters open during the day and early evening. So what that tells us is how much the solar flux and the sunspot number and the 304A is above their solar minimum values. That'll tell us how the higher bands are doing. The higher bands being 15 meters, 12 meters, 10 meters, and even 6 meters. So the daily solar flux can vary from 65 up to about 250. The daily sunspot number can vary from 0, of course, to 450 for a big solar maximum period. And the daily extreme ultraviolet can vary from about 70 at solar minimum to 500 at solar maximum. Now, the daily values are good to know, but the ionosphere is not correlated well with daily values. They're correlated with longer term values. So that's why the columns in that little chart there at the bottom say what the solar flux index needs to be for many weeks for 15 meters to be open day after day. Also, the solar, the sunspot number, what its value needs to be for many weeks, and what the EUV value needs to be for many weeks to make sure that the band is open day after day after day. And you can see that for the higher frequencies to be open, we need more solar flux, we need more sunspots, we need more extreme ultraviolet. Remember that MUF US Boulder is a real-time index of what the ionosphere is doing. So it'll give you a good indication of the F2 region, at least probably in the continental US. And of course, the real-time measurement takes into account the geomagnetic field activity, the A index, the K index, the GSR, stuff like that. So that MUF US Boulder is a pretty good index to take a look at. About the KA, BZ, solar wind, and GSR and X-rays. So what do we generally want that to be? Well, K goes from 0 to 9. It's a logarithmic scale. A goes from 0 to 400. It's a linear scale. If we go down to the bottom bullet, generally for the K index and the A index, we want the K index to be less than or equal to 3 and A less than or equal to 15 to have an undisturbed ionosphere. Now the BZ parameter goes from about -100 to +50. And we'd want the BZ parameter to be positive, or a little bit negative is okay. And that tells us that the Earth's magnetic field has not been impacted by anything on the sun. The solar wind varies from a little bit less than 400 kilometers per second, all the way up to 2,000 kilometers per second when there's a big disturbance from the sun, mostly a coronal mass ejection or a coronal hole. So we don't want the solar wind to be too much greater than 400. And that kind of assures us that the F2 region won't be too much disturbed. And for the GSR values, remember they go from 1 to 5. We'd like to see them hanging around 1, or maybe 2 would be okay. But if they get any higher, then we may have a problem with the F2 region. Now, there's just a little caveat on the right there. If the K index spikes up a bit, it's always good to take a look at the mid and low latitude pass on the higher bands to see if there might be some enhancements that can happen. And also, if there's a small spike in the K index, that could improve 160 meter propagation across the high latitudes. We have lots of observations of that happening. Now, all that data is neat, but do we really need all that data? And that's a good question to ask as more and more real-time data shows up on the internet. For example, Kilo Charlie 2 Golf takes ionoson data, puts it on a worldwide map, and then adds contour lines. Now the circles on that map are the ionoson data, and it's the MUF in megahertz. The map also shows the gray line, so that's helpful to know. And what I put in there is a path from W7 to Portugal and Spain. And if you look at the numbers and the contour lines, it looks like 30 meters could be open. So right here, you have a real-time picture of what propagation may be possible, any direction from your QTH. So this is pretty good. And of course, the measurements of the ionoson measurements of the ionosphere take into uh, consider geomagnetic field activity and everything like that. So it's a real-time measurement, and that's pretty good. Here's another example of some real-time data. This map is from dxmaps.com. It's for today between 2243 and 2343 Zulu on 17 meters. And I selected 17 meters in a picture of the world, and it shows who's working who on 17 meters. And you can see the West Coast had some openings into, looks like the Caribbean, over to Japan, down into, looks like New Zealand. So this is a good real-time picture. And of course, it tells you that the ionosphere was good enough for 17 meters, and it wasn't very disturbed due to any geomagnetic field activity because there were QSOs being made. There's similar info on PSK Reporter, WhisperNet, the Reversed Beacon Network, also the IARU Northern Cal DX Foundation beacons on 20 meters, 17 meters, 15 meters, 12 meters, and 10 meters. So there's lots of good real-time data out there that'll tell you what's actually going on, and you don't have to maybe dig too deep into all those other parameters. Now here's a picture of some long-term parameters. It's at the solon.info/solar website. And you can see in the upper left what is plotted. The planetary A index from Potsdam, the NOAA sunspot number in red, the 30-day sunspot number, the measured 10.7 centimeter solar flux, and also a 90-day average of the 10.7 centimeter solar flux. You can see that we've been at solar minimum, and that's because that solar flux is hovering around 70. But notice what happened at the end of last year. The solar flux spiked up rather dramatically, and so did the sunspot. Remember, that's just a proxy for extreme ultraviolet, and it spiked up also, and it gave us excellent worldwide propagation during the CQ Worldwide DX Phone CW contest and also the ARRL 10 meter contest. But look what happened after that spike. Things kind of settled back down to solar minimum, and that's where we are again. Okay, cycle 25. Well, I'm aware of 56 predictions for cycle 25. Why are there so many? Because we don't fully understand what generates a solar cycle. We know it has to do with plasma flow and how the magnetic field moves around inside the sun, but we just don't have all the details figured out yet. So there are many different methods of predicting solar cycles, and they range from low to very high. The chart shows the distribution of those 56 cycle 25 predictions. And I've put the prediction into buckets of sunspot numbers. For example, there's one prediction that says it's going to, the cycle 25 is going to have a maximum smooth sunspot number of between 25 and 49. Most of the predictions, 15 of them, say the smooth sunspot number is going to be between 100 and 124. And you can see it goes all the way to the right. The red annotation is what an average solar cycle does, about 179. Now, 50 of those 56 predictions, that's 89%, are for a below average cycle, kind of similar to cycle 24, which was the smallest in our lifetimes. 3 are for an average cycle, which would be kind of like cycle 23. And 3 are for a big cycle, like cycles 21 and 22. You can see those are the 3 on the far right. So let's take a look at what we can expect. Right now, we're still, doggone it, we're still at solar minimum. Cycle 25 hasn't really started up with any energy yet. hopefully it'll do that in the next couple months. We'll just have to wait and see what happens. This is a prediction for cycle 25 from the Solar Cycle 25 prediction panel, which is part of NOAA. You can see their prediction is in red. Cycle 24, the previous cycle, is to the left. The black data is the monthly mean smooth sunspot number. It's very spiky. So that's why we average it further and end up with the smooth sunspot number, which is the purple line. You can see it's pretty obvious that cycle 24 had 2 peaks. That just tells us the two solar hemispheres aren't working together. One was dominant while the other one was kind of quiet, and then that switched in time. The other one became dominant, and the original one that was dominant became kind of dormant. We don't understand that yet either. Maybe one day we will. Now, what's interesting, if you've been licensed in the past several years, you'll wonder, well, what the heck, 15, 12, and 10, why do we even have those bands? They don't do anything. Well, they do something when we hit solar maximum. So we're going to have to wait several years. But those bands are going to be very active, and you'll have a lot of fun on 15, 12, and 10. Even with your technician license. If you got a general or extra, then of course you can take full opportunity of all the frequencies. So basically 160 meters is good, going to be good now until about 2022 or 2023 when solar flares and coronal mass ejections start increasing because we're getting near solar maximum. Those are most prevalent around solar maximum. And again, 160 will be good after 2031 or so, when the occurrence of coronal holes diminishes and doesn't screw up the ionosphere too much. The coronal holes are most prevalent during the decline of a solar cycle. When's 10 meters going to be good? Well, when the solar flux and the EUV and the sunspot number get high enough to refract 28 megahertz back to Earth, bend it back to Earth. And that's probably going to happen between 2023 and 2028. So we got a couple of years to go. Gives you time to work on some antennas for 15, 12, and 10, and even 6 meters. I suspect we'll have some propagation on 6 meters at solar maximum, even if it is a small cycle. And of course, don't forget 6 meters. Sporadic E during the summer, it seems to be independent of a solar cycle. So it doesn't matter if we're at solar minimum this coming summer. We're still going to probably have some good sporadic E on 6 meters and even on 10 meters. And even at solar minimum, we can have some good trans-equatorial propagation into the deep South Africa. But for those of us at the more northern latitudes, like you guys and me in Fort Wayne, we need a link to the trans-equatorial propagation, and that will be either usually via an F2 hop or a sporadic E hop. But trans-equatorial propagation can happen at solar minimum too on the higher bands. Now, if cycle 25 ends up bigger than cycle 24, like some of those or one of those 3 high prediction comes true, then of course the higher bands will open earlier than 2022 or earlier than 2023 and stay open later than 2028. And we'll have many more years of activity if it's a big solar cycle. But like I said, 89% of the solar scientist types are thinking it's going to be a below average cycle. So we'll have to wait and see what happens. It doesn't matter what we predict, the sun's going to do whatever it wants to. So if you're recently licensed and not very impressed with 15, 12, and 10 meters, well, just wait a couple of years and you'll be pleasantly surprised. So in summary, there's lots of data available. I don't believe our amateur radio operations need all of it. I think you should focus on the basics for slides 18 and 19. That's all the parameters and what kind of values we like to see. In slides 20 and 21 are some real-time data that'll give you a good picture without looking at all those numbers. Of course, one of the best ways is just get on the air and operate. Experience is a great way to gain knowledge. You can enter contests, go after your worked all states, your DXCC, worked all zones. Especially get on the higher bands when cycle 25 gets going, because you're going to have fun, that's for sure. And here's some references to start with. For propagation, you've got the propagation chapters in the ARRL handbook and antenna book. Bob, NM7M, who's a silent key, wrote a great little book, The Little Pistol's Guide to HF Propagation. It's out of print, but it's on my website, which was referenced on the first page of this presentation. It's a 15 megabyte download, so you know, it may take a while if you've got a slow internet. The CQ Shortwave Propagation Handbook, the 4th edition, was just recently updated from the 1995 version. So it's got lots of current information in it. It talks about predictions and unusual propagation and all kinds of good stuff. So Max, that's all I had. If there are any questions, I'd be glad to try and answer them.
Yeah, we now have the repeater up also. We're broadcasting this presentation both ways with the audio. So if you're listening on the repeater, you're listening to the Portland Amateur Radio Club April meeting. And we have Carl, who's giving us a overview of space weather and also an update on solar cycle 25. And I'd like to, before we go into questions and answers, is there anybody on the repeater that would like to check in tonight? Just key up the repeater and give your call sign. All right, I don't hear anything right now. Oh, I do hear. The last station that tried to check in through the repeater, can you please come again? Hi, Pete, W7PR. Thanks for checking in. Anybody else that wishes to check in, just key up the repeater and give your call sign. All right, I don't hear anything right now. If anybody has any questions for Carl on the Zoom meeting, go ahead.
I have a question.
Hi, Fred.
Hey, the question is, how are the sunspots counted?
Well, they're counted with, you know, with humans. And way back in, let's see, it was probably 1849 or something, a guy named Rudolf Wolf said, this is how we're going to count sunspots. He thought that groups of sunspots were more important. So he multiplies how many groups of sunspots there are. I wish I had a convenient picture of the sun. You'd see what group means. And he multiplies the number of groups times 10 plus the total of all the individual spots. And then they multiply that by a, I guess you'd call it a fudge factor that takes into account your viewing conditions, your telescope, etc. So there is a definition on how to count sunspots, but unfortunately humans count them. And we can be biased and not be aware of it. So it's a interesting thing to count sunspots. And that's why measuring the 10.7 centimeter solar flux is much more objective, just as measuring the extreme ultraviolet is much more objective compared to the subjective sunspot counts.
So if I understand, when I see 13 sunspots, that probably means there is one group with 3 sunspots.
It could, yeah, you can play with the math there. And I probably should have, it'd be nice to have a picture of that, but I don't. Yeah, it's 10 times the groups, the number of groups plus the total number of sunspots. And of course, if you just have one sunspot in one group, well, you can figure that out pretty easy. It can get complicated when you have a lot more sunspots.
Okay.
And of course, it depends on how good can you see a sunspot. Is your telescope really better? And I believe that counting sunspots has at least got to the point where it's based on a certain telescope.
So the thing I'm surprised is they're not counting the sunspot using satellites with filters and things like that. So it would be more efficient than just having a guy looking at the sun through a telescope.
Yeah, well, they count the sunspot area and all that stuff, and that's all on the web too.
So one of the things I would like to add is I am new to Ham, and man, the sun weather is the most cryptic thing you can find online. There is a ton of numbers, you have no idea what they're for, and there is no clear explanation. They go on blah, blah, blah for hours on things you don't understand at the end. It's the toughest thing I found in that hobby.
Yep.
Carl, maybe just to help out with Fred and some of the other folks, if you can just kind of go back a little basic for some of the new hams on HF propagation, like the difference between what an F layer and a D layer, and which bands, for instance, the difference maybe between 40 meters in the evening and 20 meters in the daytime if you're on HF, and what that might be and what to expect.
Sure.
Maybe that'll help.
Well, yeah, that's a whole nother presentation, but I can summarize it pretty good here. The sun radiates at many wavelengths, right? From extremely short wavelengths, X-rays, gamma rays, to very long wavelengths. 10.7 centimeters is a very long wavelength. Now, certain wavelengths ionize the atmospheric constituents around Earth. And the F2 region, like I mentioned, is determined by how much radiation and extreme ultraviolet there is. And that's the highest layer of the ionosphere. It's up a couple hundred kilometers. And that's the one that's most important for long distance because it's high up. It makes a hop distance very long. In other words, the skip distance is long. Other wavelengths from the sun ionize the E region. The E region is underneath the F2 region. It's mostly a daytime because it's influenced by very short wavelengths. And of course, when the Earth rotates and the sun sets, that radiation isn't there, so the E region is diminished considerably. The lowest region is the D region. It's ionized by even shorter wavelengths, down at 0.1 to 1 nanometers. The D region mostly is responsible for reducing the signal level of the stuff we transmit. In other words, ionospheric absorption increases down in the D region, and that's why our signal strength is reduced. As we move up in frequency, it's not as great, so that's why 10-meter signals from around the world are very strong. They can be over S9, whereas 160-meter signals from around the world can be weak. And a lot of times they're at our noise level. The higher bands are best around solar maximum when there's a lot of ionization to refract the higher frequencies back to Earth. The lower bands are best at solar minimum because of the absorption issue. There's less radiation from the sun that ionizes the D region, so that means there's less absorption on the lower frequencies. What else? Let's see. How much?
Yeah, basically too, between winter and
Okay.
in fall and summer, and part of the reason I brought this up is, I've been through a few cycles, but some of the newer hams who are getting involved, let's say like in SOTA or QRP activities, and they're trying to go, when they go out and do an outing, they're trying to go, well, what bands, are going to be the most successful? And of course, it's always a bit of a variable, but if you're headed out in, deep summer as opposed to maybe, October or, that kind of a thing, to kind of explain to them, a little bit of the basics of what they might expect as a general rule.
Yeah, well, right now we're at solar minimum, so basically 20 and maybe 17 meters are going to be the highest frequencies you could probably reliably use. Okay, when we hit solar maximum for cycle 25, then you'll be able to use 10 meters and 12 meters and 15 meters day after day. Now, the atmosphere changes over seasons, and it works out that the fall and winter months are the best for production of the F2 region, whereas the summer is the least productive. So during field day, et cetera, you're going to struggle on the higher bands, especially at solar minimum, higher bands being 15, 12, and 10. But in the fall months, in the winter months, when the big DX contests are there, the ionosphere is better in the northern hemisphere. So you have some good, some decent openings, even at solar minimum. So basically what you want for the higher bands is solar maximum during the fall and winter months. And unfortunately, we're going to have to wait a couple years for that to happen. But I think we're going to see, as we move through summer into the fall, we'll see an uptick. And that'll probably occur at the same time as cycle 25 is starting to increase. So we'll get a little double shot there to have some good propagation later this fall and winter. And that's probably when, if you're interested in working, long distances on the higher bands, this fall will be a good time to do it, this coming fall.
Right. Yeah. I'm just trying to explain to some of the guys to hold on until the cycle picks up. Yep. And they're really going to be surprised.
Yes.
And how much easier it is. And they're working stations now on 20 and 40. And I just say, well, that's good experience because it's only going to get better. If you can dig them out now, boy, wait till you get on 15, which, right now is dead.
Yep.
Great. Thank you. Yeah, I just that might, kind of help people get a little more basic grasp, because a lot of the folks haven't even experienced HF radios yet. A lot of them are, still pretty new to this, and just on 2 meters. So that's what we're kind of dangling. I used to be able to go out and regularly work, with 5 watt CW, into the Far East, Australia, New Zealand, Japan, and Europe, not so much because we're on the West Coast, but you could do it, and it's something to look forward to.
Yeah, thanks, Dan. And Carl, I really appreciate you bringing up the other sites that kind of give real-time visualization of what the propagation is. I've been a ham for over 30 years, but I've not really been able to wrap my head around all the space weather
Mhm.
indices. And so that's great information. Do you find that those sites correlate fairly well with the indices?
Uh, Remember the caution I talked about. Generally, they do, yes. There are short-term occurrences that things just don't match, but on average, yes, they'll agree pretty good. You know, to think about where we may be in 10 years, your radio may download all that current stuff, and all you do is say, "Hey, I want to work Japan. What's the best band right now?" And it'll spit it out, right? All that real-time data is going to be there, and it could be interesting.
And I have heard that sometimes if people like if every ham follows the solar predictions too closely, then there would be no activity on the air except for when the solar predictions are good. But
Yep.
sometimes the most activity that I hear on the bands is not necessarily during good solar conditions, but during contests when people are actually on.
Yeah, I've always believed that the bands are open a heck of a lot more than we think, and we just don't transmit enough. And that's what contests do. You know, people get on the band and, hey, wow, the band is open. Look at that. And there's lots of good people to work. Yeah, it's pretty interesting stuff. And of course, contests are good for keeping the frequencies occupied, so people don't look at taking our frequencies, right?
Yeah, absolutely. Any other questions for Carl?
This is WA7NE. First, I want to say, Carl, great presentation.
Thank you.
And thank you for staying up late.
Yep.
I have been talking with a friend of mine, and we batter around ham things, and a question's come up between us. If you're looking at one indices to get kind of a rule of thumb, would the K index or the SFI, which one of those two would be best?
Well, they're two different things, really. One, you know, the solar flux index will tell you kind of how much ionization is there, which tells you how high in frequency you'll be able to go. The K index will tell you if that ionization is disturbed, reduced. So really, the solar flux and the K index both of them are good to have an understanding of.
So you'd want to see a high SFI and anything below 3 for a K index.
Yeah, a low K index. Yeah, that's probably ideal. Conditions for the higher bands. 15, 12, and 10 is a very high 10.7 centimeter solar flux. In the hundreds, and K indices. 2, 1, 0, and you can bet things will be pretty good.
Okay, thank you.
You're welcome. And Max, I should have mentioned when you commented about the bands and contests that our propagation predictions are statistical over a month's time frame. So the only way to validate a prediction is really to have a month's worth of data. So some people fall into the trap that the prediction's not good because things weren't right here on today. But you really have to look at the over a whole month, because our predictions are again monthly median values. They're statistical and they're probabilities. That's how we understand it at the moment.
No, that makes sense. And I know some of the indices are updated every few hours. Is that right? And others are not.
Yeah, the K index is every 3 hours. the ionoson data, at least KC2G is every 15 minutes. Some ionosons are running 5 minutes, but I think he's standardized on 15 minutes because he can capture a lot of them.
Okay, that makes sense. Thanks, Carl.
Mhm.
Any other questions for Carl?
Kind of a related question. This is Kirk, KJ7RZA.
Mhm.
And it's just a general propagation question.
Sure.
You take a band, take an average propagation date, whatever that really comes down to be.
Mhm.
And let's say you're trying to do QRP at 5 watts.
Mhm.
And you're getting someplace. I guess the question is, can you overpower the ionosphere for any given condition and day, where 5 watts is better than say 100 watts, where you're effectively maybe punching through it? I don't know. I'm just.
No, I don't think so. You've heard of HARP, right? The facility up in Alaska.
Yes.
It's called an ionospheric heater, and it transmits a heck of a lot of power. The ERP, the effective radiated power, is in the megawatts, and that's what it takes to cause the ionosphere to be modified just a bit. So our amateur power levels are so far behind, so far below that 5 watts, 50 watts, 100 watts, a kilowatt, the more power, the stronger the signal you're going to have.
So the actual propagation off the ionosphere is going to stay approximately the same bounce distance, et cetera,
Yeah.
whatever.
Yeah.
You're just going to be louder at the other end.
Yeah, one thing you got to also realize that our predictions, our understanding and our model of the ionosphere is for pure refraction. In other words, there's enough ionization to refract a signal back, but scatter occurs too. So more power may make a big difference compared to a little QRP guy. And it may not follow, take the 10 log of 50 watts over 5 watts. It may not follow that because there's scatter going on. So there's some interesting other things going on that can make things look interesting. But again, I don't think us as amateurs can generate enough power to to cause any problems.
Okay, thank you.
Yep.
Carl, I had a question. Is there generally some way to predict some of the different paths, like trans-equatorial or over the pole? Are any of these indices, would they more directly relate to trying to look for different paths in a different direction?
Well, Dan, in a very general sense, over the pole, you want a low K index, right? And trans-equatorial propagation, generally, probably the higher the solar flux, the better, the more opportunities it would have. A very general sense. Again, for you to have trans-equatorial propagation, you need a link via an F hop or a sporadic E hop to get close enough to take advantage of it.
Okay, great.
We're just in the wrong place for TEP. The guys down, in the Caribbean, and they're in our, I showed that one graph. Hold on here, way at the end. See if I can find it. No, I went past it, of course. Yeah, right here. That spike at the end of last year, Haiti worked deep into South America on 2 meter sideband, which says, the 10.7 centimeters solar flux. The sunspot number and the EUV was enough that there was transequatorial propagation on 144 megahertz, which is quite rare occurrence. Now, it'll probably happen when we get closer to solar max, but here at solar min, it was all due to that spike. For whatever reason, the sun hiccuped, and it hasn't hiccuped again yet.
Great. No, that's great. Thank you. I guess the old days of trying to look at your UHF TV channel and trying to pick up.
Yeah, that's probably gone.
It's gone.
Yeah, that's gone. It's an interesting story, transequatorial propagation. It was discovered by Hams. And it's fascinating to read about how it happened, and finally when people understood what the mechanism was.
Thank you. This has been great. It's really,
Okay.
really enjoyed it.
Mhm.
Hi, this is Nick, KI7PTT. First of all, I wanted to thank you for giving this presentation. I'm a relatively new ham, and this is fascinating stuff. I was just curious, do you personally contribute to something like DX maps when you make contacts that you feel are pretty distant and noteworthy?
I take a look at DX maps and see if there's any activity, and then hey, I better go on that band and see what's going on and see what I can work.
But unless somebody, if I understand that map correctly, unless somebody actually logs in and says, I just made a contact with this station over at this location, that's the only way that gets information.
Well, DX maps pulls spots off of packet cluster. So it's not the two stations. They have to, one of the stations has to spot the other station on packet cluster. And then the DX maps pulls it off of that. But yeah, if nobody's reporting any QSOs, there's not going to be anything there. Yep.
Yeah, it's a neat site. I was just watching it while you were, after you mentioned it. And
yep.
I could see the advantage of something like that, but it does require that everybody contribute the contacts that they made to keep it alive. So thank you.
I think there's the general human nature is, yeah, if things start heating up on that band, a lot more people are going to throw in data and show what they're working, and you'll see it.
Yeah, thanks for that suggestion.
Okay.
Cool. Do we have time for one more question, Carl?
Sure.
Anybody else with a question for Carl? All right. Any questions or check-ins from the repeater tonight? All right. I don't hear anything. Thank you very much, Carl, for that great presentation. And I think somebody put in the website already, Carl's in the chat, Carl's website, which is k9la.us. He has some great information on there, and it looks like it's updated very regularly. And I appreciate, on behalf of all of the ham radio community, resources like yours.
Well, you're welcome. I enjoyed it, Max. The cat went to bed already, so I guess it's my turn now.
Yeah, and thank you very much for staying up late. I know it's late over there.
Okay, yeah, there's one thing. I was just looking at the chat, and I should have mentioned that this solar minimum will be the most active on the higher bands because of the digital modes and their advantage in the signal to noise ratio. So you should get on the higher bands and try a digital mode. You may be surprised because they can work stuff that sideband and CW may not be able to work.
And Carl, can I ask, is that because, and you're saying the higher bands for digital, right? So that would be like 15 meters and up?
Yes.
And is that, what's the phenomenon with that higher band and digital?
Well, it's just that the digital modes can hear deeper into the noise. and that's all.
Okay.
Of course, they have that same advantage on the lower bands too.
I guess on the higher bands, nobody else is trying CW or voice, so you're free to move around the band.
Yep.
That's awesome.
Yeah,
Thank you very much, Carl.
This is actually most pertinent to things like FT8 that do work below the noise level.
Yep.
You know.
Yep.
PSK, man, maybe, but FT8 definitely will punch through where others don't.
Yep.
All right. Thanks very much, Carl.
Okay.
And coming up, we have next meeting is May 10th, and that's going to be field day planning. And we encourage everybody to come, even if you don't plan on attending either the Oregon City field day site or any of the other sites, because we're going to be discussing some pretty cool antennas that we'll be setting up. We have a 600-foot catenary line that will be stringing between a couple of very tall trees and then hanging 4 more antennas off of that. In June, we have Let's Design an Antenna Together by Fred Sierra, and Fred's on tonight. Thank you very much for volunteering to present that. That's going to be a very interesting and exciting presentation. In July, we have open still, but September, we have ham radio logging, and Mike Ritz is going to come back. He's our Northwestern ARRL division director, and he's going to talk about ham radio logging. And if anybody has any suggestions for future meetings, topics, or they'd like to actually make a presentation, please just email me at max@noltra.com.